Okay. Hello, guys, and welcome to this Java Introduction to Java Programming Bootcamp course. I hope all of you are doing well. uh, just wait a moment. Let me close this tab. Okay. So what we are going to do in this bootcamp is we'll go to the introduction of Java programming. Uh, so before that, what we are going to cover today is introduction to computer programming. So what we'll say is what is computer programming, why we are doing it, why should we learn it, if you are interested in it, what else you can learn in computer programming, how does it work, and all the topics. So sit back and relax. We'll be covering all the topics today. So let's dive deep into it. So what will be the outline of topics today is first we'll see hardware and software interface. It is very necessary to understand what's your hardware and what's your software. uh, I guess you all of you know what's hardware and software, but I'll cover that too. uh, what we'll see is layers of machine, what kinds of softwares are there, and much more. Then we'll see what kind of computer languages are like there. You must have heard computer languages like C, C++, Java, Python, Ruby, and many more. Then we'll see a little bit deep into what is syntax, semantics, grammars in computer languages. Then we'll see what happens to your program. What happens when you write your program? How does it work? How does the compilation work? The linking, the execution. Then we'll see what are the errors that you can face while you are writing a computer program and executing it. Then we'll also see what is compilation, what is interpretation. So we'll cover all those topics today. And so sit back and relax just. We'll see those topics. So let's start with software categories. So what are software? So anything that is not tangible, you can't touch it. It's software application. It does not have any hard form, real life form. It's software. It's in computer only. That's called a software. And what is hardware? So what you can feel in the real world, like your monitor or your keyboard or your mouse. This all are the hardware components. So what are the software categories which are available there? The first one is system software. So what is system software? So the programs which are written for computer systems. So back in the days when there was not invented the system software, which is operating systems, it's one of the example of system software. It used to be just only the one kernel, so it was very difficult for end users to use it. Everyone can't use the computer like that. So because of that problem, operating system and system software came into the picture. So that's what a system software is. You must have heard the terms like Windows or Mac and Linux, and other like Ubuntu, which uses Linux too. These all are the operating systems. These are system softwares. And the another type of software is application software. So what are application software? The games you play on your computer, you use Microsoft Word and documents like that. You use calculator, then you use word processor, spreadsheets, and many more. Any application that you use on your computer is an application software. Yeah, right. So let's see what's the layered view of the computer. So the first comes application programs. The programs which I told you, like word processors, spreadsheets, database software, IDEs like Visual Studio, and many more. Then comes the system softwares, which are compilers, interpreters, preprocessors, operating systems, drivers. These all are system software which are closely connected to the hardware, right? So let's move on. Now let's see what's an operating system. I give you the examples of operating systems like Mac, Windows. Most of the users will, I guess, use Windows, and Mac is also very common. There's Linux, and there are many more other Linux using operating systems like Ubuntu and another versions. So what does operating system do? So it provides a very user-friendly user interface. It loads and runs the application programs. It helps them to run. It allocates the memory, and it decides the processor time. It's very closely connected to the hardware. So the end user's task is very easy. It makes them easy to work with end users. It provides input and output facilities, managing files of information. So everything you do on computer is closely connected with operating system. So it makes your work life easier. That's what a technology is all about, right? So let's see application programs, which I told you, like any programs, right? So let's now deep dive into what is programs and programming language. So programs are nothing but what we write command series of steps in programming language. We use the term PL for programming language. It's an abbreviation of programming language. So there are many programming languages available in the market right now. The most common which you have must done during your schooling years or your graduation years are the C, C++, Java, Python, and JavaScript is also rising right now. Different versions of JS like Node and all that. So they are the programming languages. So what is a programming language? So programming language is a special purpose and limited language. What a programming language does is uh, there are some set of rules and symbols which are predefined. So it makes the works of programmer easier to write program, right? This machine, this machine does not understand anything that we say, right? It only understands the binary language, the machine language, which is binary language, which is only of consist of zero and ones. So if we try to communicate writing zeros and ones with computer, it's very difficult, right? So that's why the programming language came into the picture, so that it makes the life easier of a programmer. So there are various types of computer languages. As I said, there are mainly three types, which is machine language, assembly language, and high level language. We mostly use of high level language. We'll see what is machine languages. As I told you, this machine, your computer, does not understand anything that you write on your, let's say, notepad or wordpad, or let's say you play an game. It does not understand anything that you write or say to it. It only understands the language of zeros and ones, right? So it's called the machine language. It's machine dependent. If you try to use a machine language which is of a Windows and try to run it on a Mac, it won't run, right? So it's machine dependent. It's not portable. Then comes assembly language. So what's an assembly language is? It's a kind of a mid-level language. So it's a little bit of difficult to use, but it uses mnemonics. So it has some predefined words and symbols so that a programmer can program their anything they want to tell the computer. It's not very portable. Let's say if you're doing your graduation or you are doing your higher studies, you must have heard the term the processor 8086. So when you write the program, your program in 8086, you must have used words like move or set, or the words predefined words like that. So it's a little bit of difficult to understand. Assembly language came into the picture first. So what it does is it acts like a middle level language. So it converts the computer does not understand assembly language too, but it makes the life easier of a programmer. So it then converts it to the machine language only, which is of zeros and ones. So that is assembly language. Then comes into the picture of high level language. So what is high level languages? It's more of a human readable form. So it's like English like language. So you can understand it and write it very well. Sorry. It's machine independent, right? So as I said, it's portable. There are many examples of high level language, which is like C, C++, Java, Fortran, Python, and many more. So it's called high level language. Let's see something more about machine language. So as I said, machine language consists of what? Binary language, which is zeros and one. The number system which we use in a regular basis is what? It's to the base 10, right? But the computer understands the base of 2. So it understands only binary, which is 0 and 1. So machine instructions are in binary code. Yeah, as I said, instructions are specific operations and memory cells involved in the operations. Yeah, potato, it's all the same. Do not think uh, it's difficult, right? Just think that it's the computer only understands a language of zeros and ones. What we are doing right now, we are communicating through a language which is called English, right? There are many languages in India, like there is Hindi, there's uh, Gujarati, there's Punjabi, and much more. So what we do is understands zeros and ones. So if we want to communicate with a machine, you have to use the binary language, which is zeros and ones. So what's an assembly language? As I told you, it's a kind of like a middle level language. It's a symbolic representation of a machine language of a specific processor. So as I told you, I gave you an example of 8086, right? There is 8085 and many more. What it does is there are some predefined symbols and words which you can use to communicate better with the machine. At last, it's always converted into machine code only because the computer understands only zeros and ones, right? So usually each line of the assembly code produces one machine instruction. So if you write one instruction, it will be converted to one instruction to your computer. So programming in assembly language is slow. As I told you, it's not very high level language. You have to write one series of steps. If you want to do one command, you have to write one line for it. So it's very tedious to use. It was used back in 1900. So there is an example, as I told you, like load or add or store or price. These are some mnemonics that are predefined into the language only. So then comes into picture high level language, because we wanted to make the life easier for a programmer. Yeah. So programming language which uses statements consisting of English like words. So let's say if we want to check, let's say your parents told you, if you get 100 marks in your examinations, then I'll buy you or gift you a bike. So what's it? It's a condition, right? So we can use this English like words into our computer language, into our programming. So we say to computer, if there is something, we put a condition, and if this happens, do this, else do this. So we can use the words like English in that. There are many predefined words like print. You have to print something on the computer. You want to loop something, you can use for, and much more. So each statement corresponds to several machine language instructions. So what was happening in assembly language? If you want to do one task, you have to write one single line for it, right? Single commands for it. But it's not the point in high level language. You can use one statement and you can do many tasks in it. It's very easier than assembly language. So that's why it's very popular. So now let's see what is syntax and semantics. So let's say you are when you were little, right? You did not understand anything that came into anyone's mouth. You thought it was gibberish, blah 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 blah, right? So if you don't understand what syntax and semantics of a language, you can't communicate in it very well. So that's the case with our programming languages too. You have to understand what's the syntax and semantics to communicate with computer. So understand one thing, that computer is a very dumb machine, right? It's nothing compared to a human mind. If you want to do something, you have to tell it exactly what you want to do. So that's why you have to learn what's the grammar. Syntax and semantics is basically grammar of a language. The structure of strings in some language syntax is described by a grammar, right? As I told you, it's grammar of a language. So let's say if you try to understand a language which is called as C, you have to learn how to write in it, right? So it's called a syntax. So now as we have understood what is syntax, let's go to the compiler. So what is a compiler? So as I told you, the machine understands only binary language, right? So if you want to communicate through a programming language like high level languages, C or Python or Java, anything like that, what you are doing is you are using English like statements, right? So the machine does not understand it. It only understands zeros and ones. So we have to put a program in between, which will convert our English like statements into the machine language which a computer can understand, right? So a compiler is that program only which converts our program into a machine language so that the machine can understand what you are trying to say to it. So let's see the definition. A program that converts another program from source language or high level programming language to machine language, right? It's very easy. Some compilers output assembly language which is then converted into machine language by separated assembler. So there are many types of compiler. Let's not dive deep into it. You will get confused as it is your first day. So what happens is you write some program in your assembly or high level language. What happens is, if let's take the example of high level language only. So you write a program, right? You write a statements in English like language, then there comes the compiler in the picture. What it does is it converts into the assembly language. Yeah, the language which we told it was tedious to use and all that. So it converts into assembly language, and that then comes the assembler. What it does is it converts the assembly language into the machine language so that now the computer will understand. So what's the source program? The form in which a computer program written in formal programming language is written by a programmer. So it's always syntax and semantics. That's the source program. What's an object program? The program which comes out of a compiler. It's called as an object program, which is equivalent machine language. Yeah, right? The extension of it, if you have seen some files, there are some extensions to every files. Like if you make a PPT, it's PPTX. If you make a word, its extension is word. So the extension of an object program is .obj. And then there comes the executable program, the final form of the program, which is the output of linker or loader. So we'll see what is a linker or loader, which converts your file into .exe file, the file which the user can execute then, right? So let's say if you are clear till this, we are not going very fast. It's the basics of any computer programming language. Also, I wanted to tell you that why should we learn programming language? So it should be the first thing you should ask yourself if we want to learn it or not. So why should we learn? It's the era of technology, right? What the first thing you do when you wake up? You take your mobile, right? You see what's the time, or you scroll through the Instagram, anything or like that. So what you are doing is you are using some applications daily on your daily basis. You are now, the homes are also smart. You can just tell your Alexa to shut the lights off or turn off the fan or something like that. So we are living in the era of technology, right? So it's very, what you can say, it's very important that you understand. It's a very high going field right now. If you want to go deep dive into it, there's much larger possibility that you make a good career in it. So let's say, as I give you the example of you use your mobile phones and computers and all that. So how does that work? How can we make an application? How can we use it? So all of that can be understand if you understand a programming language. You can make some applications to make your life easier. That's why programming languages, uh, the many people are learning programming languages nowadays. So let's get back to the topic again. So we saw let's see what's a linker now. So what's a linker? So what does linker do is it merges all the programs which are needed to make a whole program. So let's say if I want to make a cup of tea, what I'll do is I'll gather some milk, I'll gather some sugar, I'll gather some water, I'll gather my stove or anything like that, and then I'll make a cup of tea, right? So it's the final product. But before that, I have to collect all that. So a linker does the same thing. It gathers all the programs which are needed to get a final output of a program. So most programs which we use consist of several modules. So if you want to write something or tell computer, so we use several modules which are already available. Say if you want to write some print statement, you want to print something on the screen, right? So what it does is there is some predefined libraries for it. It collects that library, gets the data from it, and then you can use it, right? So this work is done by the linker. Even a small program using existing code provides by the programming environment called libraries. As I told you, there are some predefined libraries. You don't have to do the work of collecting all that, but someone had to do it, right? So they are called libraries. You get your data from there and then you can use it. So linker does this work for you. It makes it easier. The linker pulls everything together, make sure that the reference to the other parts of the program are resolved, right? So how does a program runs? Let's see an overview of it. So what happens is, let's say there's a memory, as you can see on the screen. Are you able to see my cursor? Yeah. So let's see. There's a memory, right? This is your computer memory. There's your machine language program. Let's say you write your program in high level language, then it was converted into machine language program. So there is your executable file. Then if you write a program and during the execution there is some user input or something like that, so data entered during execution and then the result which is computed, so all of them goes to the CPU. There's a ALU in the CPU which does all of your calculation and that, and then it gives the output, and then the program output comes. So what it does is it has make your life easier, but in deep it's very complex, right? So let's not deep dive into it, but get the basic understanding how your computer is working, right? So you are giving everything to your computer, right? And computer is doing the work for you and giving the output. That's what is happening in the programs. So what happens during the program execution? So what happens? The CPU will fetch some instruction from you, right? Let's say you want to print your name on your screen. Let's say you want to, my name is Jay, right? So if you say you want to print Jay, uh, then you give your instruction like print Jay. You call the CPU and told him to print Jay. So CPU will fetch some instruction. Then it does not understand what is print. It's very dumb. It does not understand what does print mean. So it will decode or interpret the instruction in the binary language. Then it will retrieve some data if needed. If I provided some data, it will retrieve that. Then it will execute. The CPU will execute what you have told it to do. And then it will show you the output or store the result if you told it to do. Right. So are you guys getting the things right now? Yeah, I hope you are getting it. So let's see what are program errors now. So let me give you an example. If you're communicating to your friend, right? So you are using some words to communicate with him or her. So human mind is very intelligent, right? So if you, let's say my friend is Abhi, right? So if I called him by another name, but I'm looking at him, he'll understand that I'm calling him only, right? But it's not the thing with computers. Computer does not have intelligence like humans. So there are some uh, errors which can happen during a program. So if you write something or some part of the code wrong, it will generate some errors. It does not understand what you are trying to say. So it's very important that you write to the point programs, right? You can't just assume that it will understand. It's a dumb machine. Get it in your mind. It's very dumb machine. You have to tell it exactly what you want it to do. So let's see what are the syntax errors. So as we saw, what's the syntax? Syntax is a grammar of a language. There's some rules that we have to follow while writing some codes. So if we make a program and there is some error in the grammar of it, the syntax of it, it will generate a syntax error, which is very common. It should not happen. Then there comes the runtime error in the picture. So let's say the syntax is very correct. You return everything right, but there is a possibility that it will not run. It will stop during the runtime. Let's say in the real world, when you try to divide some number by 0, it's a classic example of a runtime error. Divide by 0. Let's say in the real world you try to divide something by 0. We haven't defined it yet here, right? So we put it as infinite or imaginary number, right? So but computer does not understand this. So if you try to divide something by 0, although the syntax is right of your program, it will give you an runtime error. It will not execute because it does not understand what you are trying to do. Let's say if you are taking you want to print uh, user's name, so you will write a program which will take user's input. So I write a program, right? I'll put it in your computer, then if you run it, it will ask for your name and then it will print your name on the screen. So if I have written a program which takes a string is how can I explain? It's gonna be difficult for you. Let's say if I write a program which takes your name, and although I have asked for the name, you try to input some numbers in it. So it will generate an runtime error because it's invalid input data. We'll see deep into it in the upcoming videos. But for now, just understand it will generate a runtime error. Then there comes the logical errors. So logical errors are nothing like syntax errors or runtime error. It will compile your program, it will run your program, but there is some logical error in it, right? The program completes execution but delivers incorrect results. So let's say if I'm trying to print my full name, so which is Jaydev, right? But it's only printing my first name, which is Jay. So although my code is correct, it's a logical error because I wanted to print my whole name and it's printing my first name only. So there are possibilities of logical errors occurring. It's very common. So let's see now how the compilation is done. As I told you, compiler is a middle program which converts your program into assembly, and then assembler converts your program into machine language. So the program which you write is called as a source program. Then it goes to the compiler. Then it converts into the assembly language if there is assembler in between, or into the machine language. So that's basically about it of it. Then there comes the interpretation. So there's a source program and then there's an interpreter and then the output come. So basically when we try to understand computer languages and programs, all that, so there are two type of programs, the middle programs, which one is compiler and second one is interpreter. So many languages use interpreter, many languages use compiler, and many languages use both. So we'll see what's the difference between both of them. So let's see first what's the interpreter. Interpreter does the same thing as the compiler. It takes the source program, it interprets it, it converts into the machine language, it then gives the output. Right. So let's say now what's the difference between compiler and interpreter. If there was a compiler, why do we need an interpreter, right? There's something always lacking in some application. So what happen in compilation is, what the compiler do is, you write your whole program, right? You write series of instruction that you want your computer to do. So what a compiler does is, it takes all of these instructions, then it compiles it and it gives the output, right? So if you have made a error, syntax error on the first line, right, but it will compile the whole program and then give you the error. So it compiles the whole program and then give you the error, although it gives you better performance because all the series of instruction are compiled in one go. So it's better performance than interpreter, but it will give you error at the last. What's the difference in interpreter is, it gives you better diagnosis. What it does is, if you write some program, it will interpret line one by one. So if you have made some error in the first line only, it will tell you that the first line is incorrect. It will not even go to the second line of the program. That's what it does. It interprets line one by one. So if you have written some code on the first line, if you have made some error, it will not go to the second line. So it interprets line one by one. So if we'll see more what dynamic binding and late binding is, but it supports it very well because it's interpreting line one by one. Let me give you an example. If you want to store some data, you want to store a 10 in your computer, right? So what happens is, uh, we have to tell computer what data type is it. So a 10 is an integer, right? So there is some storage allocated to integer data type. Let's say for most of the operating system, it's system dependable. Yeah, system dependent. It varies from system to system, but let's say 4 bytes, right? So if you want to store an integer which stores 10 and it's integer, it will take 4 bytes, right? But if you want to do that, user inputs 10 and then it will guess the data type of it, and then it will allocate the memory of 4 bytes to it. So it's good in doing that too. uh, don't worry if you don't understand this, if we'll see this in detail in upcoming videos, but it was only just for example. So as I told you, many languages use both, like compiler and interpreter. So what it does is it writes some source program. The translator converts into some intermediate language, one more intermediate program which comes into the picture. Then the intermediate program is given to the virtual machine. It converts into the machine understandable output, and then it gives you the output, right? So the basic main example for this is Java. Java uses both. So Java compiles your program first, it converts into the byte code, which is the intermediate language. Then this code is interpreted and then your output comes, right? So that's about it for the introduction of to computer programming. Uh, what we are going to do is, in this course we are going to learn Java, right? So although you are not able to understand it, let me give you an example how to write some uh, program so that you will get interested in it. Don't worry if you don't understand anything of this. It's not a big a deal. We'll see everything in detail. It's just that you get that kick. Oh, I can do this with my computer. It's not only made for doing some games and calculator and camera and applications like that. So this is a IDE which is IntelliJ. What IDE is, it allows you to write some program and run it. So this is, I am using this ID for Java. We are going to learn high level programming language which is Java in this. Java, let's talk about Java in some more detail. Java uses object oriented programming, and languages like C and which were used in 90s 19s, and it was procedural languages. Let's say we are creating, right? So what object orienting programming means is everything which you write in your computer, uh, it it is basically assuming as an object of real life. So it's all the things are converted into the object first. Don't worry if you don't understand this. I'm just talking for if some of you want to know more things. uh, so let's say I want my computer to write my name on it on the screen, right? So what I can do is, there is some uh, predefined word or you can function which is predefined, which can do this work for me. So what will I do now is I'll run this program. See, you can print your name here. Yeah, let's say you want to calculate some things and print it. Let's say I want my computer to calculate with what is 10 plus 30. I'm so dumb I can't do 10 plus 30, or I'm so lazy, so I tell my computer to do it. it gives me 40. See, so these are the things that you can do with your computer. Just explore it for your own fun. It's very interesting. You can explore it and understand what's going on here. So I give you an example of libraries, right? So see here, package Java DSA, which I have created here, which is a package. Then there's a class. Everything in Java is considered as a class. It's pure object oriented programming. Then we have created a main method. Then we are printing some data in it. So that's some basics of it. What we are going to see in this course ahead is we'll deep dive into the introduction part of Java programming, why we have to learn Java, and why not any other language, why what is Java, how does it work, what's the syntax of it, then how does this Java converts your code into the machine language, what uh, what what are the other applications that you can make with this language, and many more things in uh, this Java language. So I love Java language. Tell me in the comments what do you love, right? I personally I like Java because it's pure object oriented programming. It makes me you know, it makes me think more. I can't understand many of the times. I can't also understand what's happening here. I can't understand. That's why I love Java. It's very difficult to understand, right? You can go for languages like Python or C, but don't go for Python at the first because it's very easy to understand. If you want to learn hard things, you should go with Java only. We'll talk more about Java in the upcoming videos, not to worry. But yeah, that's the basics of it. We'll see what are the things that you can do with Java and introduction to the Java in the next upcoming video. So yeah, keep being enthusiastic, and I'll see you in the next video, right? So have a good night. Bye.